All right, everybody. Some applications. I think I want to show a couple of applications before I talk about some of the rules about definite integrals we're going to discuss today, and then I'm going to go back to applications. And we're going to kind of work back and forth. And one of the reasons being is I need you to understand some of how we apply definite integrals, and some of the things we can do in some ways to skip over evaluation and getting to another result. So suppose that we have on our x and y axis system a region that is defined by this shape right here. And let's start from 1 and let's come out here to 4. And let's make this equation y equals 1/2 x plus 1. So when I have this shape and I'm working with these values, let's see if we get it right here. I really put 4 out there ways, didn't I? Let's move it. So I'm looking for this region right here. What do you, as math students, notice about this region right here? It is a trapezoid. Do you happen to have anything in your background that can help you determine the area of a trapezoid?
A little yellowish.
Yeah, don't we have some geometry formulas that can tell us what the area of that is?
It sure does.
Somebody does anyway, right? Okay. So we can, depending on the shape that's created by the function, maybe use a geometry formula to get an exact area without evaluating the definite integral from an evaluation perspective. Here's what I need you to do first, though. Can you write the area using a definite integral for this particular situation with that particular equation?
Yeah.
So you're going, no, not a chance. So you're going, yeah, let me do it. If you think you can, please try to do that. While you are writing, I will be writing the actual answer up here that I'm looking for.
Okay. Can I talk to you about how we What was the question?
Write the definite, or the area as a definite integral.
Oh, dx. You don't write. Yeah. Oh, I thought you were supposed to do it.
Now, those of you who thought you could do it, does your answer look something like this?
Yeah. I think I should have actually done that.
Okay, please remember, we said the area, or that Riemann sum would be the definite integral from the start value of my interval to the end value, so from 1 to 4, and then it said f of x, which is just the top equation, differential dx. No, dx is not be 3. Dx is talking about very small changes. So the dx is describing a very tiny amount of movement here.
The 3 over n?
It is equated to that b minus a over n process that we had been doing in that sum and limit process. But the Riemann sum is that normed part of our partition going to 0. But yeah, it's the same idea. Now, can we get an actual number to this problem? You were telling me that you knew a geometry formula, correct? So using geometry, by the way, how tall is this?
I don't know. We don't really know. There's no numbers.
If I take x being 1 and I put that into my equation, would that tell me the height here?
Oh, yeah. Yeah. Oh, yeah. Sure.
So if x is 1, what's this height?
3/2.
If I let x be 4, what's this height?
3/1.
And then you're telling me that the length along that base is 3 units, correct? You add the bases, you divide by 2, and you think that times the height. Is that going to be an appropriate area? Add the bases, divide by 2, times the height. Is that the area? So 9/2 divided by 2 is 9/4, times 3 is 27/4. Does that look correct to you guys? Come on. Tell me your calculators figured that out too.
I'm still writing down the
Oh.
Yeah.
That's unit squared. This is area. Unit squared. Any other questions about this?
Can you re-explain
Yes, I can.
everything?
In order to establish the definite interval, I need to know what is the interval from A to B, start to finish. How wide am I looking at? And that becomes the numbers on my definite interval. The descriptor for how tall these things are is related to the equation of the top's curve. So that's the 1/2 x plus 1. That's what we're putting in here. And then the dx is always describing how wide is each of my little values or my rectangles that I'm working on. And that's where this comes from. Now, the next part down here is really related to the fact that it's a geometry shape. And so the trapezoid area is equal to 1/2 the sum of the two bases, which this is a base and this is a base, and then times the height, which in this case is actually the 3 that goes this way. That's the formula for the trapezoid that I'm using. Does that help?
No.
Other questions?
Yeah, what do you do if it's not a shape?
Well, then at this point in time, we really can't do anything because we don't know how to evaluate that using other techniques. But I need you to understand that several of these are founded on basic geometry concepts, and we can use geometry to evaluate them. Do you have a question?
Well, so you just found the area just by using the regular area?
Correct.
Not by using what's on the...
That's correct.
So we don't need to do
Yeah, that's
that.
right.
Today you are not going to be evaluating this item to find an area. That will happen next week. Okay? But I do need you to be able to write that formula because next week you're going to write the formula and evaluate it.
So we just need to write it right now.
That's exactly what I'm looking for. I'm trying to take some small steps to help us out.
Are they always going to be lines?
No, they're not always going to be long.
How are you not evaluating?
Let's try another example.
Geometry.
Let's try another example.
Oh.
Write the formula to determine. Hang in there. Were you doing okay back there?
Yeah.
You're not evaluating.
Do the instructions actually say that?
They actually do say that. Let's do this one. There you go. Let's find that one. I want the region that's right there. All 2 units of it. Or units squared of it, I should say. So I am looking for you to write a definite integral that will let me find that area if I knew how to evaluate it. That's what I want you to do in this problem. All I want you to do is I want you to write that definite integral that does this. That's all I want you to do. If you've got that, you've done it correctly. That's all I need for you guys. And no, there's not a geometry way of doing this.
Oh.
Okay, so that's different than what we did last time.
Yeah, I didn't see your like y equals e to the x little thing at first.
Oh,
and so
yeah.
I just looked down there and saw e to the x, and I was like, how is this in there?
That's the end. Does that make a little bit of sense, everybody? Can you kind of handle that? Okay.